Hello and thanks for joining this online session. I'm Takeshi Aegashi. This presentation is about building a cloud-native CI/CD pipelines for Unity games. I'm an engineer from Bandai Namco Studio in Tokyo. I love Linux, Unix, and open source culture for years. The Go language is my recent favorite. I've created some libraries and utilities in Go to manipulate Azure and Microsoft Graph resources. At my company, I'm helping various projects to lift and shift their development environment to the cloud. In this session, I'm going to cover 4 topics. They include Unity game development at our company, and Unity Build Server licensing, and Azure DevOps for cloud-native CI/CD pipelines, and last, Azure Image Builder for serverlessly customizing virtual machine images. Here's the disclaimer of this presentation. This talk is about our own experience and workflows at Bandai Namco Studios as of March 2021, and is not created, supported, or endorsed by Unity Technologies. I appreciate that Unity has allowed me to have this session in Game Stack Live. So let's get started. The first topic is Unity game development at Bandai Namco Studios, BNS in short, in the 2020s. Unity is a key component of our products for various markets and platforms. Targeting mobile, home, and arcade, we are creating so many apps using Unity game engine. But in this session, I will focus on mobile apps for Android and iOS platforms. Unity is a key component. Therefore, we've purchased and managed hundreds of Unity editor licenses. A non-small number of licenses are used to build servers. And license management and reducing costs are major challenges of our company. The next is about COVID-19 at BNS. Most developers have moved to work from home since April 2020, and there's no more people in the office. BNS is now accelerating to shift workloads from on-premises to the cloud to reduce servers and other equipment. Our Unity mobile app development has also changed. Developers are running Unity editor at home and using IT services in the office via VPN. CI/CDs are still bound to on-premises servers. Most of them are Apple Mac hardware. As you can imagine, we have various new problems including VPN inconvenience, server management difficulty, and so on. It created a need for a development method that lives in the cloud, not on-prem. This diagram is our existing CI/CD pipelines. As you see, most resources reside on-premises. There are developers' workstation running Unity editor on the left, and Perforce repository in the center, and next to it, many build servers also running Unity editor to build apps and asset bundles. The servers are governed by Jenkins CI. The apps are built and uploaded to the cloud and distributed to testers via web app on virtual machine. And this picture is our servers dedicated to build Unity mobile apps. You can see 11 units of Apple Mac Mini, now running in our empty office. Most of them are fully loaded, that is, the most expensive configuration, each pricing about $3,000 US. We want to stop using these servers. And the next diagram is our improved pipelines. As you can see, most compute resources moved to the cloud. For some reason, we still have the Perforce repository on premises, but there's a Perforce proxy in the cloud to fetch sources very efficiently. The build servers are occupied by Azure virtual machines, which are governed by Azure Pipelines instead of Jenkins CLI on premises. There are two kinds of virtual machine operating systems, Windows and macOS. I will discuss them later. We've worked on various challenges since last October to improve our CI/CD pipelines. I enumerate all of them in this slide, which will be covered later in this presentation. The most important policy would be that the solution should be in cloud native and serverless way as much as possible. In the current status, the POC has been completed, and we are aiming to apply it to our actual project. So that's all for our efforts on Unity game development at BNS. I will talk about Unity Build Server in the next section. I first talk about the license, which causes major challenges of building Unity apps in CI/CD pipeline. Unity Editor requires a license to work, and the existing license is not locked. You must assign a dedicated license to each build machine by signing in with Unity ID. Not only desktop workstations, but also automated build servers must follow the same license activation rules and processes. You might have seen these license terms. It's excerpt from Unity software additional terms, and it describes the actual condition for Unity Editor. You are requested to follow these points when using Unity Editor. The first point is, user may install Unity Editor up to 2 computers. The second, only for use by a single person. The last, user may use only one installation at any given time. And the terms has caused many problems, as I said. First, it's not suitable for managed CI services like Azure Pipelines, GitHub Actions, Stack CI, and so on. You must activate and deactivate a license for each build. It's difficult to scale because a license cannot be used in multiple builds at the same time. Next, there's the possibility of license infringement. Each license is assigned to a single person, not allowed to be assigned to team members. Last, it has expensive license costs. The full license must be purchased per build machine. To solve the problems, Unity had developed and launched a new licensing product last year. That is Unity Build Server. It's a really long-awaited license product for build servers. It's a real game changer. It features floating license. Multiple servers and users can share the same license, and it's automatically and correctly managed. But there are some requirements. You need to build and run a dedicated license server. It's available only for Unity version 2019.4.3 and later. You are allowed to run CLI batch mode only. No GUI is available. And you need Unity Pro or Enterprise subscription to purchase this license. This chart is a comparison between existing license and build server license for Unity Pro. You will notice its pricing scheme. The unit price of the build server license is much cheaper than that of the existing license, but you must purchase units of 3 licenses. And here's the outline of Unity Build Server licensing service. As I said, you need a server machine. Either Linux or Windows will do. The license server is a .NET Core application named unity.licensing.server. It's a simple HTTP REST API server that can run on common OS versions and trivial hardware specs. But it seems to use the host name, MAC address, and the number of CPUs as a server signature. You must take care. You must take care so that they won't change, especially when you use a cloud virtual machine or container. Next, I talk about some security consideration. The license server is a REST API server, but has no authentication capability. It's intended for use in the private network only. But you can mitigate this restriction by using the port forwarding feature of OpenSSH. It can establish secure tunnels that enable remote clients to access the license server. In this way, we successfully expose the license server to Unity editor in the remote network or manage the CI services like Azure Pipelines. Now we got to the end of this section. I told you about the Unity Build server licensing product and how it works. I also suggested the advanced setup with SSH tunnels to extend secure remote access. In this presentation, I omit the details of the setup and configuration, but I'll later share an article to cover it. Unity Build Server is a great product. I hope you get some useful insight from my talk and build your own server. The next section will feature Azure DevOps services. We'll see how to build cloud-native CI/CD pipelines for Unity apps. This is a diagram I've already shared with you. I will begin with the overview of managed services we adopt in our pipeline. Azure DevOps is a project hosting service of Microsoft. It provides a variety of service, including boards, pipelines, repos, artifacts, and test plans. As you already know, there are many overlaps with the services of GitHub, which is also of Microsoft. Many of them are integrated, so you can select and use the services that fit your needs, but they all have many unique and exclusive features. We choose mainly Azure DevOps because they support Azure and Azure Active Directory very well, from which we receive many benefits along with special offers for Visual Studio subscribers. Next, I talk about Visual Studio App Center. It's another service of Microsoft, formerly known as Hockey App. It has enhanced support for mobile apps. We use it to distribute apps to our testers. It also supports Azure Active Directory, so we can easily define groups to distribute our apps. And this is the main topic of this section, Azure Pipelines. It's a CI/CD pipeline service of Azure DevOps. It supports Windows, macOS, Linux building hosts. You have to put YAML files that describe jobs in your repository, like this example. You might feel it looks complicated, but once you get to know some basic tasks and configurations, it would be relatively easy to fill them out for your jobs. The Visual Studio Code extension is also available. My favorite feature is template syntax, as you can see in this example. It's useful for modularization and reuse. In my humble opinion, it's easier than writing Jenkins file in Groovy. Azure Pipelines have two types of build agents, self-hosted and Microsoft-hosted. We utilize both of them in our pipelines as shown in this diagram. The self-hosted agents are used to run Unity Editor as a build tool, running on powerful Azure Windows virtual machines to reduce build time. For Android apps, they can produce the final output, APK or AAB files, using Android SDK. But for iOS apps, they can only produce the intermediate output, that is, the Xcode project. We need macOS to build it, but it's impossible to run macOS on Azure virtual machines. So we rely on Microsoft-hosted agents of Azure Pipelines. The final output of both apps are uploaded to App Center and distributed to our testers. This shows some example of the pipeline execution results. Android app build takes 20 minutes, while iOS app build takes 36 or 7 minutes in total. The iOS build is split into two subjobs. One is Unity editor build by self-hosted agents on Windows virtual machines. Another one is Xcode build by Microsoft-hosted agents on macOS. This table is a timing comparison between our pipelines and Unity Cloud Build. Unity Cloud Build is a Unity-specific CI service by Unity Technologies. It's very handy and as cheap as $9 per month, but it's slow and less flexible. On the other hand, Azure virtual machines in our pipeline bring great flexibility and much better performance. It allows arbitrary configuration. You can choose virtual machine spec and parallelism according to the performance and the cost savings you want to achieve. Let's think about pros and cons of self-hosted agent with virtual machines. It's great that you can reduce build time with powerful virtual machines, GPUs, and other resources, but running such resources all the time would be expensive. How can we cope with this problem? The solution is to use Azure Virtual Machine Scale Set or VMSS agent pool. It's a new Azure pipeline feature added last summer. It can automatically scale the number of running virtual machines according to the number of jobs remaining in the queue. It can also automatically initialize new virtual machines, register them in the pool to make them ready, and clean up after use. Most importantly, virtual machines can be scaled to zero, which is a significant benefit in saving cost. I think this is a unique feature not available in other managed CI services so far. Azure Pipelines directly controls VMSS with Azure API, so it requires no persistent virtual machine, while other solutions need at least one host running agent to work. The setup is very easy, thanks to the tight integration with Azure. You just have to create a VMSS resource in Azure portal, then create a self-hosted agent pool in Azure Pipelines, and select a VMSS you created. You can customize the VMSS settings, including size, base images, and other features like ephemeral OS disk. I will discuss virtual machine image customization later in this presentation. This is VMSS pool settings in Azure Pipelines. You can set the maximum and minimum number of virtual machines, as well as idle time in minutes before it should stop and delete virtual machines. The operating log is also available in the Diag tab. You can see how the Autoscale is working. And here is the job execution log. It shows virtual machine boot time is about 4 or 5 minutes shown in the wait time column. There should be no delay to start jobs when there are virtual machines already started. This table shows the cost of Azure Pipelines. The cost is based on the additional parallelism you purchase, and its unit price is different for agent types and project visibility, public or private. It's charged per day basis, which means you can save more cost. You can save more cost if you set it to zero parallelism for the days you don't build. In the last, I will share the existing challenges we still have in our pipelines. First, the Xcode build is slow. We need to make it faster. Second, the VMSS agent boot takes a too long time. We need to reduce that time. Third, we want to consider running the Unity editor on Linux containers. It will greatly reduce resource footprint. The major blocker of it is compatibility. I'm looking for seeing it get out of the beta in near future. The summary of this section. I told you that we've established cloud-native CI/CD pipelines for Unity mobile game apps and how they look like. We adopt Azure Pipelines with self-hosted agents for Unity editor builds, and the Microsoft-hosted agent for macOS Xcode builds, and the Visual Studio App Center for app distribution to testers. I also talk about Azure Pipelines VMSS agent pools. It's a great feature, another game changer for us. You can easily achieve build performance improvement and cost savings at the same time. In the last section, I will discuss about virtual machine image customization. A virtual machine image is a base disk image for newly created machines. Customizing virtual machine image is a very Customizing virtual machine image is a very important practice because it directly affects the performance of builds with self-hosted agents. You can reduce build time by pre-installing build tools like Unity Editor and Android SDK, Visual Studio, and so on. This shows common steps of virtual machine image customization on Azure. You have to manipulate a virtual machine to build the image, like creating, capturing, deleting on Azure portal. The main process would be installing, upgrading the software needed for CI builds, and arranging system-wide configurations via remote shell or desktop connections. As many of you already know, the customization is a time-consuming task. The steps can be complicated and boring, therefore very prone to mistakes, so we should automate it. There are some tools and services to automate virtual machine image customization on behalf of you. The most famous tool would be HashiCorp Packer, and Azure has Azure Image Builder, AIB in short. It's a managed service and internally using HashiCorp Packer. We adopt AIB for our virtual machine image customization. Let's see some details of AIB. The good thing would be that it's a managed service. You can avoid various troubles and accidents that could happen, including cleaning up failure and resource leaks. The bad thing would be, for now, it's very cumbersome. You have to create and configure many Azure resources like storage account, MSI, and role definitions for AIB to work correctly. Additionally, there's no easy way to bring your local files into the target virtual machine. You have to upload such files somewhere on the internet and export them with proper permissions for the target machine to pull them. This shows the inconvenience of file uploading in AIB. You can see the highlighted attributes, script URI and source URI, as well as the destination path in the target virtual machine. You have to prepare these URIs by yourself to inject files into the virtual machine. As a solution, I have created a CLI tool named Customazed CLI. Customazed is a coined word that indicates a customized tool for Azure. It's written in Go language. Pre-built binaries are available for Windows, Linux, and macOS. It helps you with cumbersome setup and painful file uploading tasks, which are optimized to various Azure services, including AIB. Here's an example of how file upload assistance works. The highlighted text are processed by Customazed CLI. You can embed the upload function in the Go language template syntax in JSON configuration files. It recognizes the path of the local file, uploads it to the pre-configured storage, then replaces it with the download URL. By adapting Customazed CLI, our developers can easily set up and iterate virtual machine image customization. It supports most major development environments and offloads many cumbersome but necessary tasks such as file uploading. You can see the sample project for building Unity apps in GitHub, so please try it out with your Azure subscription. Okay, conclusion of this presentation. We've shared our efforts on building CI/CD pipelines for Unity apps on the cloud. It's global trends driven by the COVID-19 pandemic imperative. And it's about our challenges in the development environment of Unity in the 2020s. We established the POC with the several key components. The first component is Unity Build Server. It's cloud-ready license for CI/CD, with SSH tunnels for secure access extension to remote build servers. The next one is Azure Pipelines for the cloud-native CI/CD pipelines. It's with VMSS agent pools for improving the build performance and cost efficiency at the same time. The last one is Azure Image Builder for the serverless virtual machine image customization, with customized CLI for providing easy setup and developers assistance. I've shared some sample projects and resources related to this presentation. Unity project named RostCrypt is based on the sample from Unity technologies and hosted in GitHub. And there's Azure DevOps project to build RostCrypt app for Android and iOS. You can see actual build logs of Azure Pipeline there. App Center distribution is also available. You can download application images. I also share customized CLI projects to build virtual machine images for CI/CDs. In the last slide, I would thank the people who kindly supported this session from Unity Technologies Japan and Microsoft Japan. And I also thank you for joining this session. I hope it's useful and helps you to build your own cloud-native CI/CD pipelines for Unity apps. Thank you so much and take care.